Okay, this last section does have a program for every section that we've done. So we're going to be doing the hypothesis testing just like we did in the last chapter. And our rule still applies. We'll be finding a p-value. So if your p-value comes out smaller than alpha, you will reject the hope. And if the p-value comes out greater than or equal to alpha, you will fail to reject the hope. So I only have 4 examples here, one of each program. And I only put one link in instead of all 4. So I'm just going to write down the program number because they're all numbered on this guy's website. So number 31 is the one that goes with our first section where we were doing 2 large samples, and which makes it a z-score. So I'm going to call that the 2-samp z. Then we moved on to independent small samples. That one is number 32, is 2-samp t test. Then section 3 was the dependent samples where you had like a before and after the same group. That one is calculator number 34, the 2 dependent samples. And then the last section we did was the difference between proportions, and that is calculator number 33. And I'll show you how to get to all of these. I only have, I believe, this one linked. I don't know why that's that one. One of them's linked. I don't even know. So 33 is the 2 proportion, 2 prop z. So those are the 4 programs. I have one link, and I'll show you how to get to them. So before we get started, I want to write the ho and ha. You have to do these even though you're using a program. So a guidance counselor claims that high school students in a college prep program have higher ACT scores than those in a general. So the claim is that the average ACT, those that are in college prep, I'll use CP, is higher than the general. Now we write that as a difference. So I'll have the mean of the college prep minus the mean of the general is going to be greater than 0. That makes that the ha. The ho is that the difference will be less than or equal to 0. And if I write down the important information, I do like to organize it so I get everything right. So the mean score for the ACT, and not that you have to do this on your paper, there were 49 of them. The mean was 22.1, and the standard deviation was 4.8. For the general education, there were 44 of them. So definitely big samples. The average was 19.6, and the standard deviation was 5.4. Okay, so we're just going to enter these 6 values in with our ha sign, and it's going to give us a p-value, and we're going to compare it to 0.10. All right, so now I'll switch gears and show you how to enter all of that in. So I'll go to, let's see, I'll go a tab. And I already have it open. So I believe this is the one that I have linked. Oh, maybe not. I'm just going to go with it. So the one we want, because this is a large sample, is test 31. So go to 31. And open up. And you can see for sample, second sample. There we go. So first sample, we my ACT are 49. Sample mean was 22.1. Standard deviation 4.8. Second sample 44. Mean was 19.6. 5.4 for the standard deviation. We have to pick the ha sign just like before. Now our ha has a greater than in it, so we'll click the greater than. Confidence level. This is confidence intervals also. We're not going to get into anything else just to calculate. Now, it is getting weight T down here, but it's automatically a Z because if you look at the way he titled this, it says 2 independent samples, population, standard deviation known. That makes this a Z score. So he's got a little bit of program. He's a great value for a Z. So don't worry, that's a T. Your probability is 0.010. And we don't want in the LB, the UB, we don't want any of that. So P equals 0.010. Now, so that's 1%. This is 10%, so the P is definitely smaller than alpha. So we will reject the ho. And the claim was the ha. And that would make the claim true. So the program we used here was number 31, does the 2-samp Z. We'll just put Z by it, so you know. Okay, let's go to the second one. No, it's not sharing. Stop. Stop. Stop presenting. Okay, so one, number 2. Again, you got to write the claim. So test the claim at 1% that the mean annual incomes in Delaware and Greene counties are the same. So claim mean Delaware. The same means they're equal. Writing it as a difference, so we'll mean Delaware minus mean of Greene would equal 0. That makes the claim the whole. So the ha will be not equal to 0. Let's get the data down. So this is Delaware. We had a sample of 17, small sample. Mean was 31,200. Standard deviation, 7,800. In Greene, sample was 18. Mean income, 29,500. Standard deviation, 73.75. Population variances are equal. For that pool. Okay, these are small sample. Small sample, that's a T, that's calculator number 32. I'll share that. I'll go back to the last one. I was on 31, that's what it's going to take me to. So to get to 32, you just hit the contents tab in the left corner here. So if I hit contents, I can go right here and scroll down to number, what did I just say, 32. 32. And he just titled it 2 independent samples with SAS. He doesn't have the pool not pulled in here. I know what that's how we do. Sample. 17. Mean. 31,200. So 7,800. Second sample 18. Mean 29.5. Standard deviation 73.75. Now not equal to ha. And calculate. Our p-value is 0.513. Our alpha was 0.01. So it is definitely bigger. That's our fail to reject the whole. And that would be neath. Evidence to say it's false. Okay, next one. Table shows the gas mileage of 8 cars with and without using a fuel additive. So these are the same cars with and without. So this is that dependent sample thing. So this is 2 dependent, which is always t-scores. Okay, we'll get the claim down. Is there enough evidence to conclude that the fuel additive, so the with fuel additive, improved gas mileage? So you can write this either way. So I'll go the mean without the additive and compare that to the mean with the additive. And it's better with the additive. So without will be smaller than with. Now flip-flop them, that's fine. Just make sure you put them in the right order in the tables. So that makes that the ha. I do the subtraction. So mean without minus mean with will be less than 0. The whole will be greater than or equal to 0. And the program lets you just enter the data in, so we don't have to write down any data. It's all there. So we'll go to dependent is number 34. So we'll go there. Show you how that works. No, it's still there. Okay, I'm gonna go back. And we'll do this. Sharing this tab, we're going to go to contents and switch to 34. So down 34. Tells you take the values, so let's read. And the values separated by commas, but no spaces. So the data you want, I'm going to type them in. So 35.8. Comma, no space, 37.7, comma, 39.4, comma, 36.8, comma, 36.6, comma, 33.7, comma, 38.4, comma, and 37.3. No comma. Now put it into the same way. 36.2, make sure you keep the order right, comma. 39.8, comma. 40.1. 39.3. 36.9. 34.5. 38.8. And 39.1. And our ha sign has a less than. Selected. And we're going to calculate. And again, the only thing we want is this p-value in here. It's like 0.004. So p equals 0.004. The alpha was 0.1. So P is smaller than alpha. That's our fail to reject the whole. Oh, sorry, that's our reject the whole. Reject the whole. Making the claim true. Okay, and then our last one is stuck on the side here. Let's see, in a 1990 study, 1,539 adults, 520 said they used alternative medicines. So there's our sample size and our number of successes. In a recent study of 2,055 adults, 865 said they used alternative medicines in the previous year. Can you reject the claim that the proportion of adults using alternative medicines has not changed? So the claim would be that the mean from 1990 in a recent study, so recent, and it says that has not changed, which would make them equal. So the difference would equal 0, making that a whole. The ha would be not equal to 0. And now we go, because this is proportions, the key word in there, the proportion. Ooh, I have the wrong symbol. Ooh, bad P's. These should be P's, not means. P's, all bad. -1 for me. That P, that claim being a proportion, is going to tell me to come to this section. Look how easy that was to just automatically do means. So the proportion. Got it. Okay, so that test is, the proportion test is number 33. And you're going to see how easy that is. Just go over to the contents. Go down to 33. So the first sample had 1,539 with 520 successes. Second one, 2055. And 865. The ha has a not equal to. Okay, wait. And again, the p, look at this, I want you to miss this. You have 4.156. Remember, this is probability, this can't be over 1. Look at the end of the line, it's times 10 to the -7. That's very small. So with a p-value of 4.15 times 10 to the -7, remember this should never ever be over 1. So if it's written like that, it's probably scientific notation. So it has 6 zeros. So it's essentially 0. And now you can compare it to alpha. Definitely smaller, so we're going to reject the whole here. And the whole, what's the claim? So the claim is false. There is a difference in the number using alternative medicine. Sorry, I had to squeeze that in, but that's it. The programs are pretty easy. They run the same rules as last time. So hopefully you got all of that. Stop recording.